तो अब आता है एक्सक्रीटरी प्रोडक्ट्स एंड देयर एलिमिनेशन। तो इसमें है जो ह्यूमन एक्सक्रीटरी सिस्टम देखेंगे, फिर इन्फॉर्मेशन, फंक्शन ऑफ द ट्यूब्स, मैकेनिज्म ऑफ द कॉन्सेंट्रेशन ऑफ द फिल्ट्रेट, रेगुलेशन ऑफ द किडनी फंक्शन, मिक्सचुरेशन, रोल ऑफ द अदर ऑर्गन्स इन एक्सक्रीशन और डिजॉर्डर्स ऑफ द एक्सक्रीटरी सिस्टम देखेंगे। तो एक्सक्रीटरी प्रोडक्ट्स एंड देयर एलिमिनेशन इसमें कहता है कि एनिमल्स एक्यूमुलेट अमोनिया, यूरिया, यूरिक एसिड, कार्बन डाइऑक्साइड, वाटर and the ions like the Na plus, K plus, chloride and phosphate, sulfate, etc. either by the metabolic activity or by the other means like the excess ingestion. These substances have to be removed totally or the partially. In this chapter, we will learn the mechanisms of the elimination of these substances with the special emphasis on the common nitrogenous waste. Ammonia, urea and uric acid are the major forms of the nitrogenous waste excreted by the animals. Ammonia is the most toxic form and requires large amount of water for its elimination, whereas the uric acid, being the least toxic, can be removed with a minimum loss of the water. The process of the excreting ammonia is the monotelism. Many bony fishes, aquatic amphibians, and aquatic insects are ammoniotelic in the nature. Ammonia, it is readily soluble, is generally excreted by the diffusion across the body surface or through the gill surface in the fish as the ammonium ions. Kidney do not play any significant role in its removal. Terrestrial adaptation necessitated the production of the lesser toxic nitrogenous waste like the urea and the uric acid for the conservation of the water. Mammals, many terrestrial amphibians and the marine fishes mainly excrete urea and are called the ureotelic animals. Ammonia produced by the metabolism is converted into urea in the liver of the animals and released into the blood, which is filtered and excreted out by the kidney. Some amount of urea may be retained in the kidney matrix for some of the animals to maintain a desired osmolality. Reptiles, birds, land snails, and insects excrete nitrogenous waste as uric acid in the form of the pellet or the paste within a minimum loss of the water and are called as the uricotelic animals. फिर कहता है कि a survey of the animal kingdom represents variety of the excretory structure. In the most of the invertebrates, these structures are simple tubular forms, whereas the vertebrates have the complex tubular organs called the kidney. Some of these structures are mentioned here. Protonephridia or the phloem cells are the excretory structure in the platyhelminths, platforms, example planaria. Rotiferous elnids and the cephalochordate amphioxus protonephridia are primarily concerned with ionic and the fluid volume regulation, that means osmoregulation. Nephridia are the tubular excretory structure of the earthworm and the other annelids. Nephridia help to remove the nitrogenous waste and maintain a fluid and the ionic balance. Malphizian tubules are the excretory structure of most of the insects, including cockroaches. Malphizian tubules help in the removal of the nitrogenous waste and osmoregulation. Antennal glands for the green gland perform the excretory function in the crustaceans like the prawns. फिर आता है ह्यूमन एक्सक्रीटरी सिस्टम। तो इसमें ये ह्यूमन यूरिनरी सिस्टम दिया हुआ है, जिसमें एंटीनल ग्लैंड हो गया, ये रीनल आर्टरी हो गया लाल वाला, और रीनल वेन हो गया, फिर किडनी, फिर डॉर्सल आयोटा हो गया लाल वाला, डॉर्सल आयोटा नीचे से हो गया, और रीनल आर्टरी जो हो गया वो ये वाला हो गया, और रीनल वेन नीचे से दिखाया है वाइट वाला जो है ये है रीनल आर्टरी ब्लू रेड वाला। फिर यूरेटर हो गया, यूराइनी ब्लैडर हो गया, यूरेथ्रा हो गया। फिर इंफीरियर वेना केवा, इधर पेल्विस हो गया, मेडुला, और इसका है जो कॉर्टेक्स हो गया। तो ह्यूमन एक्सक्रीटरी सिस्टम तो कहता है कि इन द ह्यूमन्स द एक्सक्रीटरी सिस्टम कंसिस्ट ऑफ अ पेयर ऑफ द किडनी, वन पेयर ऑफ द यूरेटर्स, अ यूरिनरी ब्लैडर एंड a urethra. Kidney are the reduced prawn bean-shaped structure situated between the levels of the last thoracic and the third lumbar vertebra, close to the dorsal inner wall of the abdominal cavity. Each kidney of an adult human measures 10 to 12 cm in the length, 5 to 7 cm in the width, or 2 to 3 cm thickness, with an average weight of the 120 to 170 gram. Towards the center of the inner concave surface of the kidney is a notch called the hilum, through which the ureter, blood vessel, and the nerves enter. Inner to the hilum is a broad funnel-shaped space called the renal pelvis with projection called the calypige. The outer layer of the kidney is a tough capsule. Inside the kidney there are two zones, an outer cortex and the inner medulla. The medulla is divided into a few conical muscle medullary pyramids projecting into the calypige, similar calyx. The cortex extends in between the medullary pyramids were the renal columns of the Bartini. Each kidney had nearly 1 million complex structure called the nephrons, which had the functional unit. Each nephron had two parts, the glomerulus and the renal tubule. Glomerulus is a tuft of the capillary formed by the afferent arteriole, a fine branch of the renal artery. Blood from the glomerulus is carried away by the efferent arteriole. The renal tubule begins with a double-walled cup-like structure called the Bowman's capsule, which includes the glomerulus. Glomerulus, along with the Bowman capsule, called the Malphizian body or the renal corpuscle. The tubule continues further to form a highly coordinated proximal comminuted tubule. तो इधर है जो लॉन्गिट्यूडनल सेक्शन डायग्रामेटिक ऑफ द किडनी दिया हुआ है। इसमें ये आ गया मेडुलरी पिरामिड, फिर कैलिक्स आ गया, रीनल आर्टरी आ गया, रीनल वेन आ गया, रीनल पेल्विस आ गया, यूरेटर आ गया, फिर रीनल कैप्सूल, कॉर्टेक्स और रीनल कॉलम है जो आ जाता है। फिर यहाँ पर दिया हुआ है डायग्रामेटिक रिप्रेजेंटेशन ऑफ द नेफ्रॉन शोइंग ब्लड वेसल, डक्ट एंड द ट्यूब्यूल। तो इसमें ये हो गया इफरेंट आर्ट्रियोल, एफरेंट आर्ट्रियोल, ग्लोमेरुलस, बॉमन्स कैप्सूल, प्रॉक्सिमल कम्युनिकेटिव ट्यूब्यूल, डिस्टल कम्युनिकेटिव ट्यूब्यूल, कलेक्टिंग डक्ट, बाइफा रेक्टा, असेंडिंग लूप ऑफ हेनली, डिसेंडिंग लूप ऑफ द हेनली हो गया, और इधर हेनली लूप हो गया। फिर आता है कि PCT, a hairpin shaped Henle loop is the next part of the tubule which has a descending and an ascending limb. The ascending limb contains either another highly coiled tubular region called the distal convoluted tubule DCT. The DCT of the many nephron open into a straight tube called the collecting duct, many of which converge and open into the renal pelvis through the medullary pyramid in the caliphage. The Malpighian corpuscles PCT and the DCT of the nephron are situated in the cortical region of the kidney, whereas the loop of the Henle dips into the medulla. In majority of the nephrons, the loop of the Henle is too short and extends only related into the medulla. Such nephrons are called the cortical nephrons. In some of the nephrons, the loop of the Henle is very long and run deep into the medulla. These nephrons are called the juxtamedullary nephrons. Different arterioles emerging from the glomerulus forms a fine capillary network around the renal tubule called the parietubular capillaries. A minute vessel of this network runs parallel to the Henle loop, forming a U-shaped bifida recta. Bifida recta is absent or highly reduced in the cortical nephron. तो मैल्फिजियन बॉडी रीनल कॉर्पस्कल से प्रॉक्सिमल कॉन्वोल्यूटेड ट्यूबुल दिया हुआ है, यहाँ पर बॉमन्स कैप्सूल है और इफरेंट एट्रियोल है, इधर एफरेंट एट्रियोल है, इफरेंट से एग्जॉस्ट होता है। फिर यूरिन फॉर्मेशन के बारे में लिखता है कि यूरिन फॉर्मेशन इन्वॉल्व्स थ्री मेन प्रोसेस, नेमली द ग्लोमेरुलर फिल्ट्रेशन, रीअब्जॉर्प्शन एंड द सिक्रेशन दैट टेक प्लेस इन द डिफरेंट पार्ट्स ऑफ द नेफ्रॉन। द फर्स्ट स्टेप इज द यूरिन फॉर्मेशन is the filtration of the blood which is carried out by the glomerulus and is called the glomerular filtration. On an average, by 12 ml of the blood is filtered by the kidney per minute, which constitutes roughly 1/5 of the blood pumped out by each kidney of the heart in a minute. The glomerular capillary blood pressure causes filtration of the blood through the three layers, that means endothelium of the glomerular blood vessels, the epithelium of the Bowman's capsule, and the basement membrane between these two layers. The epithelial cells of the Bowman capsule, called the podophytes, are arranged in an intricate manner so as to lead from minute spaces called the filtration fluids or the fluid pore. Blood is filtered so finely through these membranes that almost all the constituents of the plasma except the protein pass onto the lumen of the Bowman capsule. Therefore, it is considered as a process of the ultrafiltration. फिर कहता है द अमाउंट ऑफ द फिल्ट्रेट फॉर्मड बाय द किडनी पर मिनट इज कॉल्ड ग्लोमेरुलर फिल्ट्रेटेड रेट, फिल्ट्रेशन एट GFR. GFR इन द हेल्दी इंडिविजुअल इज अप्रॉक्सिमेटली 125 ml per minute, 150 liters per day. The kidney have inbuilt mechanism for the regulation of the glomerular filtration rate. One such efficient mechanism is carried out by the juxtaglomerular apparatus JGA. JGA is a special sensitive region formed by the cellular modification in the distal convoluted tubule and the afferent arteriole at the location of their contact. A fall in the GFR can activate the JG cells to release the renin, which can stimulate the glomerular blood flow and thereby the GFR back to the normal. A comparison of the volume of the filtrate formed by per day, 40 liters per day, with that of the urine released 1.5 liters suggests that nearly 99% of the filtrate had to be reabsorbed by the renal tubules. This process is called as the reabsorption. The tubular epithelial cells in a different segment of the nephron performs this either by the active or the passive mechanism. For example, substances like the glucose, amino acids, NAPLS, etc. in the filtrate are reabsorbed actively, whereas the nitrogenous based are absorbed by the passive transport. Reabsorption of water also occurs passively in the initial segment of the nephron. During the urine formation, the tubular cells secrete substances like the H plus, K plus, and the ammonia into the filtrate. Tubular secretion is also an important step in the urine formation as it helps in the maintenance of the ionic and the acid-base balance of the body fluids. फिर आता है फंक्शन ऑफ द ट्यूबुल। तो कहता है कि PCT लाइनर बाय द सिंपल क्यूआडल ब्रश बॉर्डर epithelium which increase the surface area for the reabsorption nearly all of the essential nutrients and the 70 to 80% of the electrolytes and the water are reabsorbed by this segment. PCT also helps to maintain the pH and the ionic balance of the body fluids by the selective secretion of the hydrogen ions and the ammonia into the filtrate and by the absorption of the bicarbonate from the it. Henle loop. तो कहता है reabsorption is mainly in its ascending limb. However, this region plays a significant role in the maintenance of the high osmolality of the medullary interstitial fluid. The descending limb of the loop of the Henle is permeable to the water but almost impermeable to the electrolytes. This concentrates the filtrate as it moves down. The ascending limb is impermeable to the water but allows the transport of the electrolyte actively or passively. Therefore, as the concentrated filtrate passes upward, it gets diluted due to the passage of the electrolytes to the medullary fluid. फिर डिस्टल कॉन्ट्रैक्टर ट्यूबुल तो कहता है कंडीशनल रीअब्जॉर्प्शन ऑफ Na+ when the water take place in the segment. DCT is also capable of reabsorption of bicarbonate and the selective secretion of hydrogen and the potassium ions and the NH3 to maintain the pH and the sodium potassium balance in the blood. तो यहाँ पर दिए हुए हैं reabsorption and the secretion of the major substance at the different parts of the nephron. Arrow indicate the direction of the movement of the materials. तो यहाँ पर H+NH3 बाइकार्बोनेट NaCl बायो न्यूट्रिएंट्स हो गया. NaCl का इधर प्रॉक्सिमल कम्युलेटिव ट्यूबुल है, डिस्टल कम्युलेटिव ट्यूबुल है. तो इधर है जो एब्जॉर्प्शन हो रहा है इधर, और इधर है जो K+H+ का सिक्रेशन हो रहा है. H+NH3 का सिक्रेशन हो रहा है, कॉर्टेक्स में है ये दोनों. डिफेंडिंग लूप ऑफ हेनली है जहाँ पे H2O का रीअब्जॉर्प्शन हो रहा है, NaCl का रीअब्जॉर्प्शन हो रहा है. थिन सेगमेंट ऑफ डिफेंडिंग लिप से, थिन सेगमेंट ऑफ डिफेंडिंग से भी NaCl का हो रहा है. कलेक्टिंग डक्ट से यूरिया का है जो रीअब्जॉर्प्शन हो रहा है, और थिन सेगमेंट ऑफ द असेंडिंग लिम्ब में उसका है जो सिक्रेशन हो रहा है. फिर H2O का भी रीअब्जॉर्प्शन कलेक्टिंग डक्ट से हो जाता है. फिर इधर से बाइकार्बोनेट NaCl H2O न्यूट्रिएंट्स और K+ का है जो रीअब्जॉर्प्शन PCT से हो जाता है. फिर आता है कलेक्टिंग डक्ट. तो this long duct extends from the cortex of the kidney to the inner parts of the medulla. Large amounts of the water could be reabsorbed from the phloem to produce a concentrated urine. Thin segment allow passage of the small amounts of the urea into the medullary interstitium to keep up the osmolarity. It also play a role in the maintenance of the pH and the ionic balance of the body blood by the selective secretion of H+ and the K+ ions. So the mechanism of the concentration of the filtrate. तो कहता है कि mammals have the ability to produce a concentrated urine. The Henle loop and the Bhaffa recta play a significant role in this. The flow of the filtrate in the two limbs of the Henle is in opposite direction and thus forms a counter current. The flow of the blood through the two limbs of the Bhaffa recta is also in the counter current pattern. The proximity between the Henle loop and the Bhaffa recta equalize the counter current in them, help in the maintaining and engaging osmotic towards the inner medullary interstitium from the 300 milliosmol in the cortex to about 1200 milliosmol per liter in the inner medulla. This gradient is mainly caused by the NaCl and the urea. NaCl is transported by the ascending limb of the loop of Henle, which is extended with the descending limb of the Bhaffa recta. NaCl returned to the interstitium by the ascending portion of the Bhaffa recta. Similarly, a small amount of the area enter the thin segment of the ascending limb of the Henle loop, which is transported back to the interstitium by the collecting tubule. They have described transport of the substance facilitated by the special arrangement of the Henle loop and the Bhaffa recta is called the counter current mechanism. This mechanism helps to maintain a concentration gradient in the intermedullary interstitium. Presence of such interstitial gradient helps in an easy passage of water from the collecting tubule, thereby concentrating the filtrate urine. Human kidney can produce urine nearly 4 times concentrated than the initial filtrate formed. 4 टाइम कॉन्सेंट्रेटेड हो सकता है. तो ये यहाँ पर दिया डायग्रामेटिक रिप्रेजेंटेशन ऑफ द नेफ्रॉन एंड द भाफा रेक्टा शोइंग द काउंटर करंट मैकेनिज्म है जो दिखा रहा है. इसमें 300 मिलीओस्मोल हो गया, 600 मिलीओस्मोल, 900 मिलीओस्मोल, 1200 मिलीओस्मोल. ये भाफा रेक्टा इधर नेफ्रॉन का हो गया. ये कंसेप्ट है कि डिफेंडिंग में जो होगा दोनों के लिए वाटर परमेबल होगा और दोनों में असेंडिंग के लिए है जो NaCl परमेबल होगा. फिर कॉर्टेक्स हो गया, आउटर मेडुला हो गया और इनर मेडुला हो गया. बॉमन कैप्सूल हो गया, ग्लोमेरुलस हो गया. H2O है जो डिफिटी से निकल रहा है. इधर 200 मिलीओस्मोल दिखाए हुए, 300 मिलीओस्मोल यहाँ पर है. डिफिटी में 200 मिलीओस्मोल ही है. फिर NaCl है जो निकल रहा है, यानी ऑब्जेक्शन H2O और NaCl का हो रहा है डिफिटी से. ये इफरेंट एट्रियोल हो गया और ये हो गया एफरेंट एट्रियोल हो गया. उसके बाद फिर आता है रेगुलेशन ऑफ द ह्यूमन किडनी. तो Ncert कहता है कि the functioning of the kidney is efficiently monitored and regulated by the hormonal feedback mechanism involving the hypothalamus, JGA, and to a certain extent the heart. Osmoreceptors in the body are activated by the changes in the blood volume, body fluid volume, and the ionic concentration. And excessive loss of the fluid from the body can activate the receptor which stimulate the hypothalamus to release the antidiuretic hormone ADH or the vasopressin from the neurohypophysis. ADH facilitates water reabsorption from the latter parts of the tubule, thereby preventing diuresis, and increase the body fluid volume can switch off the osmoreceptor and suppress the ADH release to the complete the feedback. ADH can also affect the kidney function by its constrictive effects on the blood vessel. This causes an increase in the blood pressure, and increase in the blood pressure can increase the glomerular blood flow and thereby the GFR. The JGA play a complex regulatory role. A fall in the glomerular blood flow, a glomerular blood pressure GFR can activate the JGFS to release the renin, which converts the angiotensinogen in the blood to the angiotensin 1 and further to the angiotensin 2. Angiotensin 2 being a powerful vasoconstrictor, increase the glomerular blood pressure and thereby GFR. Angiotensin 2 also activates the adrenal cortex to release the aldosterone. Aldosterone causes the reabsorption of the Na plus from the water from the distal part of the tubule. This leads to an increase in the blood pressure and the GFR. This complex mechanism is generally known as the renin-angiotensin mechanism (RAS). An increase in the blood flow to the artery of the heart can cause the release of the arterial neurotropic factor ANF. ANF can cause the vasodilation of the blood vessel and thereby decrease the blood pressure. ANF mechanism thereby act as a check on the renin-angiotensin mechanism. तो कहता है micturition, तो कहता है कि यूरिन formed by the nephron is ultimately carried to the urinary bladder where it is stored till a voluntary signal given by a central nervous system CNS. This signal is initiated by the stretching of the urinary bladder as it gets filled with urine. In response, the stretch receptor on the valves of the bladder sends signals to the CNS. The CNS passes on the motor message to initiate the contraction of the smooth muscles of the bladder and the simultaneous relaxation of the urethral sphincter causing the release of the urine. The process of the urine is called the micturition and the neural mechanism causing it is called the micturition reflex. An adult human excretes on an average 1 to 1.5 liter of the urine per day. The urine formed is a lightly yellow colored watery fluid which is slightly acidic, pH 6.0, and has a characteristic odor. On an average, 25 से 30 gram of the urea is excreted out per day. Various conditions can affect the characteristic of the urine. Analysis of the urine helps in the clinical diagnosis of the many metabolic disorder as well as malfunctioning of the kidney. For example, presence of the glucose, glycosuria, and the ketone bodies, ketonuria in the urine are indicative of the diabetes mellitus. फिर कहता है रोल ऑफ द अदर ऑर्गन्स इन द एक्सक्रीशन, तो कहता है अदर देन द किडनी, लंग्स, लिवर एंड द स्किन also help in the elimination of the excretory waste. Our lungs remove the large amount of the CO2, approximately 2 milliliter per minute, and also significant quantity of the water every day. Liver, the largest gland in our body, secretes bile containing substances like the bilirubin, biliverdin, cholesterol, degraded steroid hormones, vitamins, and the drugs. Most of these substances ultimately pass out along with digestive waste. The fat and the feces glands in the skin can emit certain substances through their secretion. Fat produced by the fat gland is a watery fluid containing NaCl, a small amount of the urea, lactic acid, etc. Though the primary function of the fat is to facilitate a cooling effect on the body surface, it also helps in the removal of the some of the waste mentioned above. Feces gland emits certain substances like the sterols, hydrocarbons, and the backside through the sebum. This secretion provides a protective oily covering from the skin. Do you know the small amount of nitrogenous waste could be eliminated through the saliva too? इसके बाद डिजॉर्डर्स ऑफ द एक्सक्रीटरी सिस्टम है, तो कहता है कि मेल फंक्शनिंग ऑफ द किडनी कैन लीड टू द अकुमुलेशन ऑफ द यूरिया इन द ब्लड, अ कंडीशन कॉल्ड यूरेमिया विच इज हाईली हार्मफुल एंड may lead to the kidney failure. In such patient, urea can be removed by a process called hemodialysis. During the process of the hemodialysis, the blood drained from a convenient artery होता है, pumped into a dialysing unit called the artificial kidney. Blood drained from a convenient artery is pumped into a dialysing unit after adding an anticoagulant like the heparin. The unit contains a coiled fallopian tube surrounded by a fluid dialysing fluid having the same composition as that of the plasma except that nitrogenous based. The porous fallopian membrane of the tube allows the passage of the molecule based on the concentration gradient. As nitrogenous based are absent in the dialysing fluid, these substances move freely out, thereby clearing the blood. The cleared blood is pumped back to the body through a vein after adding antiheparin to it. This method is a boon for thousands of the uremic patients all over the world. Kidney transplantation is the ultimate method in the correction of the acute renal failure. Kidney failure, a functioning kidney is used in the transplantation from a donor, preferably a close relative, to minimize its chances of reaction by the immune system of the host. Modern clinical procedures have increased the success rate of such a complicated technique. Renal calculata stone or the inferior mass of the crystallized salts of fluids which are formed with the kidney, or glomerulonephritis for the inflammation of the glomeruli of the kidney. फिर समरी में इसका समरी में एनसीईआरटी कहता है कि मैनी नाइट्रोजन कॉन्टेनिंग सब्सटेंस ions, CO2, water, etc. that accumulate in the body have to be eliminated. Nature of the nitrogenous based formed and their excretion vary among the animals, mainly depending on the habitat, ability of the water. Ammonia, urea, and uric acid are the major nitrogenous based excreted. Protonephridia, nephridia, Malphian tubules, green glands, and the kidney are the common excretory organs in animals. They not only eliminate nitrogenous based but also help in the maintenance of the ionic and the acid base balance of the body fluids. In humans, the excretory system consists of the one pair of the kidney, a pair of the ureters, a urinary bladder, and a urethra. Each kidney has over a million of tubular structure called a nephron. Nephron is the functional unit of the kidney and had two portions, glomerulus and the renal tubule. Glomerulus is a tuft of the capillary formed from the afferent arteriole fine branch of the renal artery. The renal tubule starts with a double-walled Bowman capsule and is further differentiated into a proximal convoluted tubule (PCT), Henle loop, and a distal convoluted tubule (DCT). The DCT of the many nephrons join to a common collecting duct, many of which ultimately open into the renal pelvis through the medullary pyramid. The Bowman capsule encloses the glomerulus to form the malphizian or the renal corpuscles. फिर कहता है कि urine formation involves three main processes: filtration, reabsorption, and the secretion. Filtration is a non-selective process performed by the glomerulus using the glomerular capillary. Blood pressure: about 12 ml of the blood is filtered by the glomerulus per minute to form the 125 ml of the filtrate in the Bowman capsule per minute. JGA, a flat portion of the nephrons, play a significant role in the regulation of the GFR. Nearly 99% of the reabsorption of the filtrate take place through the different part of the nephrons. PCT is the major site of the reabsorption and the selective secretion. Henle loop primarily helps to maintain the osmotic gradient 10 millioosmoles to 12 millioosmoles per liter within the kidney interstitium. DCT and the collecting duct allow the extensive reabsorption of water and the floating electrolytes, which help in the osmoregulation. H plus, K plus, and H3 could be secreted into the filtrate by the tubules to maintain the ionic balance and the pH of the body fluids. A contact end mechanism operates between the two limbs of the loop of the Henle and those of the Bhaffa acta capillary parallel to the Henle loop. The filtrate gets concentrated as it moves down the descending limb but is diluted by the ascending limb. Electrolytes and the urea are retained in the interstitium by this arrangement. DCT and the collecting duct concentrate the filtrate about 4 times. That means from the 10 millioosmol to 12 millioosmol per liter. An excellent mechanism of the conservation of the water. Urine is stored in the urinary bladder till a voluntary signal from the sinus carries out its release through the urethra. That means micturition. Skin, lungs, and liver also assist in the excretion. तो ये इसका है जो एनसीईआरटी हो गया एक्सक्रीशन का.